So, the other night, I was laying in bed wondering, is it possible for a spaceship to reach light speed? Well, I figured that the best way for the spaceship to accomplish this would be to remain in orbit, accelerating until it passed light speed, just constantly increasing while remaining in orbit. However, the spaceship would surely reach the escape velocity for the planet. Or so I thought. So I began my research. So the formula for escape velocity is the velocity equals square root of 2 times g times the mass divided by the radius of the planet, or the distance from the spaceship to the center of the planet. G is a constant, m is mass, and the velocity is escape. So I set the velocity to light speed, and the mass would be the mass of the planet, and then I would try to find the distance and see if it was possible for the object to be in orbit when it reaches this. So for the Earth, with a radius of 6.371 million meters and a mass of 5.97 times 10 to the 24, in order to reach light speed, the spaceship would have to be exactly 0.0088 meters from the center of the planet. Unfortunately, the Earth's radius is a bit larger than that, so the spaceship would be inside the planet and it wouldn't work. Of course, there are some bigger objects in space than the Earth, so what if we managed to get the spaceship to be going around the Sun, orbiting? So the Sun, slightly bigger, 695 million meters from the radius to the outside. Its mass, 6.673 times 10 to the 30th kilograms. So now, to reach light speed for the spaceship, it would have to be 2,953 meters from the center, which unfortunately is still quite a bit smaller than 695 million meters, and would be inside the Sun. Luckily, the Sun is not the biggest object in the universe. There are black holes. The center of the Milky Way, there's Sagittarius A, which is 4.31 times 10 to the 6 times the mass of the Sun. Its radius, 1.8 times 10 to the 13. And to reach light speed, the spaceship would have to be 1.27 times 10 to the 10 meters from the center of the planet, which unfortunately is still inside the black hole, which is still inside the black hole. But Sagittarius A isn't even the biggest black hole out there. The biggest black hole that we have discovered is TON 618, which is 66 billion times the mass of the Sun. And in order for the spaceship to reach light speed while orbiting around it, it would have to stay under 1.9 times 10 to the 14 meters from the center of the planet, of the black hole. Unfortunately, the radius is 1.292 times 10 to the 14 meters from the center of the black hole, and that's the biggest object in the known universe. So the main problem with reaching light speed while remaining in orbit is that black holes just aren't dense enough. Even though the mass is increasing compared to suns and planets, the radius is also much bigger, and that means the spaceship ends up being inside the object and not in orbit. So, since the biggest black hole, TON 618, does not even have enough density to allow the spaceship to remain in orbit, the only object we can use is your mom.